Hey, we're going to move on here in logic, and we're going to talk today about conditional statements. This is a really important lesson in the unit. So make sure you add this to your concept list. So when I say conditional statements come in the form if, then. Call them if-then statements. And they have two key components. They have a hypothesis, which we give the symbol P, and that's all the stuff that follows the word if. Then we have a conclusion, which we assign the letter Q to, and that's all the stuff, all the words that come after then. So in symbols, and we'll add some more meaning to this, I'll show you some examples. In symbols, an if-then conditional statement looks like this, where the hypothesis P comes first, and Q comes second, the conclusion. And this arrow represents a conditional statement. So we could read this symbolically as if P, then Q. Another way to say that would be P implies Q. If we want to draw a picture to represent that, we can draw a Venn diagram, which you might have some experience with from science classes. And so we have one big circle and one little circle. The little circle represents P, and the big circle represents Q. So if you're in the P circle, then you are also in the Q circle. So let's give this some more meaning. Let's actually put some words to this. So I want to identify the hypothesis and the conclusion of this conditional statement, and then I want to draw a Venn diagram to represent it. So my statement is, if an animal is a robin, then the animal is a bird. So the stuff that comes after the word if is my hypothesis. So my P, my hypothesis, is an animal is a robin. Notice I didn't add the word if in there. The hypothesis is just the stuff after that word. The conclusion is the animal is a bird. It's all the words that come after the word then. So my conclusion, Q, is the animal is a bird. And then if I draw a Venn diagram, it's a circle inside a circle, and the littler circle is always the hypothesis P. So if a bird is in the robin circle, it's also in the bird circle. So if it's a robin, then it's a bird. Let's do one more closely related to geometry. Here, the words after the word if are going to be my hypothesis. So an angle measures 130. That's my hypothesis P. The words after then are my conclusion. The angle is obtuse. Oops, sorry about that. I accidentally deleted the page. Sorry, guys. So there it is. The conclusion Q is the angle is obtuse. Again, if I want to draw that as a Venn diagram, P goes in the smaller circle. So 130-degree angle, I just wrote 130 because it fit better, goes into the circle of all the obtuse angles. So not all obtuse angles are 130, but if it's 130, it's definitely obtuse. So I want you to pause here. I want you to try this one. Just identify the hypothesis and conclusion like we did on the previous page, and then draw a Venn diagram. So here the words after if are two angles are vertical. That's my P, my hypothesis. The words after then are they share a vertex. That's Q, my conclusion. And so my hypothesis P, angles being vertical, that's going to be my small circle. My big circle is going to be angles that share a vertex. And so this is what a Venn diagram would look like. So we've talked about counterexamples in the previous lesson, and so it's helpful to know the truth value or whether or not a statement, a conditional statement, is true. And if we can give one counterexample for a statement, then that means it's false. So in this conditional statement, if a woman is French, then she is European. Let's think about that. If somebody's from France, then they're also from Europe. So that means if somebody is French, then they are European. So this is a true statement. The second one, if a number is divisible by 3, then it is odd. So we got to think of some numbers that are divisible by 3. 6 is divisible by 3, but 6 is not odd. 9 is divisible by 3, but it's odd. 12 is divisible by 3, but it's not odd. So we have a couple counterexamples in 6 and 12. So this is a false statement, since I can find even numbers that are divisible by 3. So here's a conditional statement. I want you to determine if it's true or false, and if it is false, give me the counterexample. So make sure you pause and try this one. So if two angles form a linear pair, then they are supplementary. That is actually the definition of a linear pair. So this is a true statement. Linear pairs always add up to 180 degrees. They make straight lines, and so this is a true statement. So this part is a big deal. It's probably useful if you pause here and write all this stuff down before I talk about it, or listen to it and then write it all down. Don't try to do them both at the same time. We have all these things called related conditional statements. So if we start with our original if P then Q statement, we can sort of move the hypothesis and conclusion around a little bit, and we can create these related conditionals. So if I switch P and Q, switch the hypothesis and conclusion, we call that the converse. So we would actually have if Q then P. Let me fix that. If we negate the hypothesis and conclusion, so basically we're changing the meaning. A lot of times that means you're adding the word not, or you're taking away the word not. And that little squiggly in front of P and Q means to negate. So the inverse is if not P, then not Q. If we combine the converse and the inverse, we get what we call the contrapositive. So we get if not Q, then not P. And last, if we have a conditional statement that is true, and then we write its converse, and we find out that its converse is also true, then we can write the biconditional. So we can only write it if the conditional and its converse are both true. And so a biconditional has a double arrow between them, and it's written P if and only if Q. So you write your hypothesis, say if and only if, then you write your conclusion. So just like at the beginning, this is going to make a lot more sense when we actually take one of these conditional statements and make the related conditionals. So let's do that. So here we have this original conditional. If an angle measures 180 degrees, then it is a straight angle. And we know that's true because straight angles, straight lines are 180 degrees. So this is a true conditional statement. I'm going to pick out its hypothesis and conclusion, so that'll help me write these related conditionals easier. So my hypothesis P is an angle measures 180 degrees. My conclusion Q is it is a straight angle. So the converse is going to be me writing Q first and then P. So if I picked out P and Q like this, I can just write them in the correct order. So I start with Q and say if it is a straight angle, then an angle measures 180 degrees. So I just switched the order of P and Q. And this statement is also true. So later on, I will be allowed to write the biconditional since the original statement is true and so is the converse. Here I want to write the inverse. So I stay in the right order, P, then Q, but I have to negate them. So to change the meaning of an angle measuring 180 degrees would be to say that an angle doesn't measure 180 degrees. I also have to change the meaning of the conclusion, so I will change it to, then it is not a straight angle. To do the contrapositive, I just kind of do both, the converse and the inverse. So I switch their order and I change their meaning to get, if it is not a straight angle, then an angle doesn't measure 180 degrees. Since my conditional and its converse were both true statements, I can write a biconditional. So I take P and I start with it. An angle measures 180 degrees. Put in there if and only if, and then I add Q. It is a straight angle. So there's no if-then here. I just take my P and Q, and in between them I write the words if and only if. So my biconditional says an angle measures 180 degrees if and only if it is a straight angle. So pause here. I want you to do just what we did on the last slide. Use this conditional statement, figure out the hypothesis and the conclusion, then write the converse, inverse, and contrapositive. And if both the conditional and the converse are true, write the biconditional. So pause this, give it a shot, take a few minutes, and then you can check your answers. So if this month is June, then next month is July, that's totally true. July comes after June, so that's a true conditional. My hypothesis P is this month is June, and my conclusion Q is next month is July. To get the converse, I'm going to switch their order. If next month is July, then this month is June. That's also true. If I negate P and Q, I get the inverse. If this month isn't June, then next month isn't July. So the only way for next month to be July is for it to be June. So if this month isn't June, then next month isn't July. The contrapositive is doing both, switch their order and negate them. If next month isn't July, then this month isn't June. And then since our conditional and our converse were both true statements, we can write the biconditional. If this month is June, if and only if next month is July. So we just did a bunch of stuff. I have some questions for you to answer on a form. So make sure you click the link below in the description section, sign in and answer the questions on the form, submit your answers, and then show me your notes.